So in tutorial 6, we'll be looking at the health impacts of climate change. And I think first of all, I'd like to just reflect here on the idea that there's so many examples of health impacts, and it's kind of classified and grouped quite well in this diagram. So in the center here, we can see that we have more extreme weather, which has impacts on health based on ecology and pollution, but also with rising temperatures here, we see severe weather events and extreme heat. We've got rising sea levels, which are going to have impacts on water quality and increasing allergens. And then we've got, of course, increasing CO2 levels, which is going to lead to environmental degradation and water and food supply impacts, which all in turn have major impacts on different health scenarios. So it might be worthwhile taking a good look at that and thinking about how you would use that to introduce the idea of health impacts, perhaps in a longer essay. But I'm going to give some evidence now of some of these examples of health impacts. And the first one I want to look at then is kind of water health impacts. And in this map, we see a kind of index of climate sensitive health effects. And they're looking here at diarrhea, malaria, inland and coastal flooding, and malnutrition between the time period 2000 and 2030. And there's a very striking pattern that shows that Africa as a whole is most climate sensitive in terms of health effects, in particular Southern Africa and East Africa. We really mustn't neglect looking at South Asia and Southeast Asia, in particular Indonesia. So they're all seeing really quite high mortality rates in regard to these particular health problems that are all particularly sensitive to climate change. So I'll develop a couple of examples here, and the first one is in Southern Africa, and it's Botswana. We're going to look at diarrhea. So when we think about diarrhea, we'd probably associate this firstly with kind of poor sanitation, poor water quality, and health impacts leading to diarrhea. Of course, that's very treatable in developed country contexts, but in developing countries, especially with the vulnerable children and elderly, this has a major impact on mortality. But this study, which was conducted by a US team between 1974 and 2003, showed a very interesting pattern. They showed that, of course, the wet season did produce a peak in diarrheal cases, as we'd expect. But interestingly, they saw a 20% increase, and the highest rate was seen within the dry season. And this was thought to they hypothesized that this was due to kind of the insects that would be spreading these conditions. And of course, in these hotter, drier conditions, you have more insects around. So climate change, where it's producing these extended drought periods, is likely to increase diarrheal cases, but also during wet seasons we see further peaks, so they kind of get a double whammy. Another example here can be seen in Bangladesh. Now we know Bangladesh is this very low-lying deltaic country. We've got Bangladesh here, it's a coastal zone, and it's the lowest coastal zone in the world, but 36 million people are living in this area here, shaded in brown. And you can see actually by the blue line, you see the coastal border, and then you can see actually the orange line here represents salinity. So we're seeing this failure of the soil, this increasing salinity level that's moving into that previously fertile soil. And the high tidal limit shown here, which goes right across here following certain river channels and covering Dhaka. So huge numbers of people facing water stress issues in terms of their fresh water supply and in terms of safe drinking water and salinity issues. So here we're going to see this unfolding problem to do with access to food, access to safe drinking water. So another example that I want to look at then would be kind of vector-based health issues and ecology-based health issues. And the first thing we might think about here is, well, okay, yeah, that malaria seems to be moving northwards, and yeah, that there is good evidence of that. So a study has shown that disease-carrying mosquitoes are expanding their range by over 150 miles every year. But I think a lot of students are going to talk about that. And what I think I'd like you to develop here is perhaps the idea of the patterns of vector-borne diseases with patterns of monsoon and El Nino. So what we're seeing an increased case of malaria epidemics that follow patterns of particularly excessive monsoon rainfalls and high humidity. And in addition to that, we're seeing malaria epidemics that increase with frequency alongside El Nino events. So El Nino is to do with that Pacific Ocean current, and the frequency and severity of El Nino events seems to be increasing with climate change, and that's bringing about increased frequency of epidemics. So in addition to malaria, of course, there is dengue fever, and a study has shown that dengue fever has increased 3,000% in the past 50 years alone, and is continuing to spread to new countries. So that's a particularly worrying trend in one vector-borne disease. And you might be thinking the one that springs to mind most is the Zika virus. So the Zika virus, which hit Brazil hardest, if you remember, during their Olympic preparations in 2014 and 15. So this disease is known for that really scary impact on young babies, microphilia. And then what we have here is we've got really the global distribution of the Aedes aegypti mosquito, which is known to spread this disease, and it also is known to spread dengue fever. But it's not just tropical regions which are facing vector-borne diseases. So this graph shows the increase in Lyme disease in Europe, and you see a really quite stark, rapid rise. Of course, some seasonal shifts, some changes in patterns, but we see this trend line of rapidly rising Lyme disease. So with warmer Western and Northern European climates, we're seeing the tick, which typically is bound to kind of deer and feeds on the blood of mammals in our forests, is sort of increasing in density, and it's certainly increasing in density in high latitudes and high altitude European countries. So this is a particularly scary one. So future climate change in Europe will facilitate a spread of Lyme's disease into these high latitudes and high altitudes. So we're really seeing rapid rises in a lot of different countries. It talks here of Austria, Germany, Czech Republic, Slovenia. But living in Belgium, we're also seeing here rapid sort of localized incidents of Lyme disease, particularly in some of the forested areas. Another example of health issues which might be worth reflecting on is extreme heat in terms of heat stress deaths in the UK. So we've got heat stroke and heat exhaustion sort of compared here in this graphic. But certainly, again, in Western Europe, Northern Europe, temperate climates, we're going to see an increase in heat stress related deaths. And this is due to a combination of factors, heat stress, dehydration, and this will affect, in particular, more vulnerable people in the population, our elderly, for example. So we see in this graph, we see the numbers of cold-related deaths falling. So we're seeing this change in mortality and morbidity based around climate. So you can see from the 2000s to 2080s, we expect to see a decline in cold deaths. This is just showing the same for Wales. And we see it for different age groups here. From 65 to 74, we see a decline in cold deaths. At 75 to 84, we see a more significant decline. But in the most vulnerable group in our population, we're seeing that rapid decline in cold deaths. And that's mirrored, or is that the right word? It's contrasted by that rise in hot deaths, in heat-related deaths. So again, we're seeing from the age of 65, small increases over time in that age group. But as we get to the 85 pluses, we're seeing significant increases in heat-related deaths. So climate change certainly having an effect as well on that.